Okay, so hey everyone, welcome to the series of courses, as of which the first course is Amazon Web Services, and it has a lot of lectures. I hope you travel with me through this entire journey so that you gain a lot of knowledge. So whatever's there in my mind, I put it out there. So I hope you guys appreciate it. So let's get started with the AWS introduction. But before that, let's just take a second to talk about me. So I have worked with cloud platforms for the last 3 years and have extensive knowledge on the AWS platform and all of its service offerings. So I have all of the associate level certifications of AWS and also my DevOps professional cert that I wrote last year on September 13, 2019. And then for me, it's always like learning is an everyday process and it's always an exponential curve. So on the left, you see all of the certifications that I have completed. And in the middle, you see the organizations that I worked for. And on the right side, you see my contact number as well as my email address if you want to reach out for any further queries and so on. So what is Amazon Web Services and what does it bring us? So Amazon Web Services is a cloud computing platform that gives you access to servers, storage, databases, and a broad set of application services over the internet. It's a cloud service provider such as Amazon Web Services. They own and maintain the network connected hardware that is required for them to provide you with all of these application services, wherein you provision what you need, and they will take care of the underlying infrastructure and so on. So they give you a very nice console view. And most of all, throughout this entire course, we will be looking at all of the different services from the console aspect. But always remember that AWS also provides you with CLI access, and it also provides you with a lot of different programming languages support in order for you to create your infrastructure and work with their service offerings. So it offers reliable, scalable, and inexpensive cloud computing services. So the more we deep dive into Amazon Web Services, you'll be able to relate as to what's reliable, as to what's scalable, and what is their pricing model for each and every service, right? So you get to know that you are free to join, but then you pay only for what you use. So if suppose you launch an EC2 instance, which is a virtual machine, you'll be paying by the hour. If you go ahead and do a code build job for building your application, you will be paying per minute. And if you go ahead and use the latest offering, which is Lambda functions, which is a part of the serverless framework, you will be paying per 100 milliseconds, right? So there are different pricing models that they give you, and you get to choose which service you would like to work with, and depending on which you are subscribing to that pricing model, right? So let's move on to see some of the reasons as to why you need to use AWS. So it's mainly depending on the location. So because AWS has a lot of locations, so they have at least around 23 geographic locations. I think they recently introduced the Africa location, right? And then you also have automated multi-region backups. And the more we deep dive into certain AWS services like EC2, S3, or probably with RDS and so on, you'll be able to see how this automated multi-region backups can be done. And we have streamlined disaster recovery, where you can configure an active configuration with your disaster recovery region, or you can go with an active passive configuration, and you have routing policies regarding the same. We'll talk more about those. And then you also have the reason as consistency and reliability, because they provide a really good SLA for some of their services, and they provide a really good durability for their storage service, which is the 11 nines durability. And when we work with the storage service, we'll be able to understand that in more clarity. And when it comes to flexibility and scalability, Amazon Web Services provides you with manual scaling, with automated scaling, with schedule-based scaling, and you can increase your capacity at any point of time. You can decrease your capacity at any point of time. So you can choose from a wide variety of scaling choices that they provide. And you can go with the pay-as-you-go pricing model, which is hourly based or minute based, and they also have second-based billing for some of the Linux instances, and millisecond-based billing for Lambda functions. You also get really good security because they follow a lot of different compliance programs, and then you can also learn about security in transit, security of data at rest. How do you secure your infrastructure when you create it? How do you ensure that no one from the internet is able to access your infrastructure? Something like that. And then AWS also integrates with a lot of third-party APIs. So you'll see a lot of tools that I talk about going through this entire course content, that you will know that other than just the console and the CLI access to AWS, you can also have SaaS-based offerings that integrate with AWS. One good example would be for compliance purposes, you have a SaaS-based offering called Prisma Cloud, which is, finds out whether your cloud environments are compliant with different compliance policies like HIPAA or PCI DSS compliance and so on. You also have Dynatrace for APM monitoring, application performance monitoring, which also seamlessly integrates with AWS. So you have a lot of these, third-party applications or SaaS-based applications that integrate with AWS natively, out-of-the-box functionality by just providing your access keys or by creating an IAM role. So these are some of my reasons as to why you need to go ahead and choose AWS. And from a understanding point of view, for myself, I have found it much more familiar to start off with AWS and then go on to other cloud platforms like GCP or Azure or Oracle Cloud and understand them in much more detail, because this guy has been in the industry for a really long time. Right? So when you do a comparison between AWS, GCP, and Azure, you can see over here that 68% of production applications are running on AWS, you have 58% of applications running on Azure, and then you have 19% of applications running on Google Cloud Platform. So this is from 2018, this particular screenshot. So you can go ahead and search on Google as to what's the current percentage of applications that's running on these platforms, right? So Gartner has, he's a person who mentions this. So he has mentioned that clients typically choose GCP as a secondary provider rather than a strategic provider, though GCP is increasingly chosen as a strategic alternative to AWS by customers whose businesses compete with Amazon. And that AWS and Azure are more infrastructure or DevOps centric, whereas GCP is more along the lines of developer centric. So I would say, if you're an infra person, if you're working as a system administrator or network administrator, learning about AWS and Azure's breadth of services regarding the infrastructure as a service based cloud offering, I would say that those two are much far ahead than where Google is right now. So that's my verdict, but then it depends upon people's opinion when they have worked with that respective platform. Right? Some of the benefits of cloud computing is that you get agility. So it allows you to innovate faster because you focus on your valuable IT resources on developing applications that differentiate your business and transform customer experiences rather than managing infrastructure and data centers. You also get the elasticity when you move to the cloud because you can provision your instances or your virtual machines at on-demand capacity, and at the same time you'll be able to scale these virtual machines whenever you want to within the matter of minutes, and you don't have to wait for a day or two for your virtual machine to start. You can just get started and you can scale up and down, you can scale in and out, which is vertical scaling or horizontal scaling, right? And you can do all of this within the matter of minutes. So that's the kind of benefit that it provides regarding scalability, right? And you can deploy globally in minutes. So when we are working with AWS, there's a particular service that we will be working with, which is called as Amazon CloudFront, which utilizes 216 points of presence across the entire world that they have set up. And this provides you with that capability of very low latency to your end users, and at the same time deploying your application globally within the span of minutes. So within 20 minutes, you have your application which is globally deployed, and any end user at any corner of the world will be able to hit your application with very low latency. And then you have cost savings because it allows you to trade capital expenditure for operational expenditure, right? So that's called as CapEx and OpEx. So CapEx is capital expenditure, that the money that you spend on setting up data centers or physical servers and so on, whereas operational expenditure is something that is regarding your ongoing costs and your ongoing infrastructure costs and so on, right? For your day-to-day operations and so on. So that is operational expenditure. So Amazon Web Services and any other cloud-based platform, they allow you to trade capital expenditure for operational expenditure. So in that way, you're paying your bill on a monthly basis, and you're consuming services as and when you need. And it's a pretty cool pricing model, I would say, because you can get started with the AWS with just zero cost and then build out your own startup for your organization. You can start leveraging the cloud, and their breadth of services and their depth of services is amazing. So it's pretty cool. Yeah. And some of the cloud service models that are there in the industry, probably some people would say that there are a lot more. But according to me, we have software as a service, platform as a service, infrastructure as a service, container as a service, and then you have functions as a service, right? So let's look at software, platform, and infrastructure in more detail. We are not going to go ahead and look at container as a service or function as a service, but in those respective modules that we study about Docker containers or we study about Lambda functions, we will look at this in a little bit more detail later, right? So let's get started with software as a service. So software as a service is a model where you get quick access to a cloud-based web application. Your vendor controls the entire computing stack, and they just give you the access through a browser, right? And these applications that probably would be running on a cloud-based platform, you pay them for license basis, right? So let's say, for example, you're going to work with Dynatrace. It's around $10 that you're going to pay per month, and their underlying infrastructure that they are probably using to host their SaaS or their software, that could be in any cloud platform, for example, right? So that's why classic examples for this are Google G Suite, where you pay around 130 rupees in Indian rupees for extra, 150 GB of storage, sorry, for every 100 GB of storage that you want, for your Google Drive, right? And similarly, you have Microsoft Office 365 where you have to purchase licenses, and then you have Dropbox in the background where you have Amazon S3 as the backend, I believe. So for all of these platforms, you pay on a license basis or a subscription basis, but then they are providing you a software over the internet that you are leveraging, and their respective infrastructure of that software is being hosted on a cloud-based platform. So that's called as software as a service. So similarly, when you go to platform as a service, in this particular cloud-based offering, where you can go ahead and develop, you can go ahead and test, you can go ahead and organize your different applications, but then they take care of the underlying infrastructure in terms of provisioning the underlying infrastructure, or managing and maintaining that underlying infrastructure from the OS level stack to the bottom. They take care of it, right? But where you are given a platform where you can just go ahead and develop your application, test and organize your application, and so on. So classic examples for this is Google App Engine and AWS Elastic Beanstalk, and we have a separate section on AWS Elastic Beanstalk, where you can get a really good idea as to why it's called as a platform as a service based offering. Because you go ahead and deploy your application. That's the maximum you got to do. You got to give it an artifact, and the underlying infrastructure for that particular application to run is being taken care of by AWS Elastic Beanstalk itself. So that's why it's called as a platform as a service based cloud delivery model. The next one that we have is infrastructure as a service. So this is where you manage literally everything by yourself, right? So infrastructure as a service is basically a virtual provisioning of a computing resource over the cloud. So you get the entire access to the underlying infrastructure along with the networking, the storage, and the server that you would like to manage and maintain. It's totally your responsibility. So that's why the classic example is Amazon Web Services, Microsoft Azure, and Google Compute Engine for Google Cloud Platform, right? So AWS and Azure are both on the infrastructure as a service based, a cloud delivery model. So they have services that range through the other cloud service models also, but then they are more from the infrastructure oriented, as well as Google Cloud Platform is more from the developers point of view. Right. And Amazon Web Services has their own service called as EC2, which is Elastic Compute Cloud, which is to go ahead and create virtual machines, which falls under infrastructure as a service. Whereas Microsoft Azure has their own concept of infrastructure as a service called as virtual machines, right? Where you get access to the underlying infrastructure directly. So everything is your own, your responsibility, wherein you go ahead and patch and maintain that operating system and that underlying hardware. You go ahead and upload your application onto it. You open up your networking firewalls. So everything is your responsibility when it comes to infrastructure as a service. Let's just take a small look at Amazon Web Services history. So in the year 2003, they designed the documentation. In the year 2004, their first service, which was called as SQS, was launched. In the year 2006, we had AWS officially being launched. And in the year 2010, we had around 180,000 developers who are working on the platform to bring it as to how it is today. In the year 2010, Amazon.com's underlying infrastructure, right? It was totally moved to Amazon Web Services, which is their shopping website. And then you had an incident in the EBS book in the year 2011. And in the year 2012, you had their first reInvent conference. It's a 5-day event, I believe, that happens in the US. And it's pretty cool because you get to know a lot of different technologies. You have a lot of different clients and customers who are presenting their own stalls. And then you have a lot of different services that are being introduced. So it's pretty cool, that particular conference. And in the year 2013, their certifications were launched. In the year 2014, they committed towards achieving 100% renewable energy. The year 2015, their revenue was around $6 billion US. It has been increasing about 30% year on year. In the year 2016, it was $13 billion US. In the year 2017, they hosted their own artificial intelligence services. So they started working a lot towards machine learning and artificial intelligence from the year 2016 itself, I would say. And in the year 2018, they had machine learning specialty certifications that were launched, right? This is a brief history of how AWS came into existence, right? So now let's go ahead and look at one important concept, which is AWS certifications. So to be pretty honest and brutally honest over here, AWS certifications are pretty tough to do. It's not that you just go into the exam with just 1 week or 2 weeks of preparation and you go ahead and crack your exam and come out. So it's not that easy, right? And they have segregated it into different levels. So you have the foundational level where you have the cloud practitioner. You have the associate level where you have solutions architect associate, sysops administrator associate, and developer associate. In the professional level, you have solutions architect professional and the DevOps engineer professional. On the specialty level, you have 6 right now from March 2020 onwards. So you have advanced networking specialty, security specialty, machine learning specialty, Alexa skill builder specialty, data analytics specialty, and database specialty. So after 2019, there was actually no prerequisite for writing a certification. You could be a novice and you can just study for 3 months or 4 months for a specialty certification, and you can directly go ahead and crack it based on your experience in the market, right? So you don't need to do a foundational cert in order to go ahead and do an associate or a professional or a specialty, right? So that criteria was removed, right? And it's total of around 12 certifications right now. I think it's 12, right? If I'm mistaken, if I'm not. Yeah, it's 12 certifications right now from 2020 March onwards, right? So in the year 2018, they had 11 certifications, right? So why would a person do a certification, and what is the difference between a person who does one and who does not do a certification? So that's also something that's important to remember, because I mean, you may be working for an organization that is AWS's own business partner, right? So in that particular use case, the more certifications you do, the more partnership levels they increase. With AWS, right? So that's one good advantage. The other advantage is, I would say, the more certifications you do, the more theoretical and practical knowledge that you would get. So I would always suggest approaching any topic from a certification point of view, because you at least study that particular content in its depth, right? And you go on to write a certification exam that validates your knowledge. So the other benefit is that I would say when you're sitting for placement interviews, or when you're going for an organization for an interview, whether you're an experienced candidate or a fresher, I mean, doing certifications, it's always really good, because that's how the industry is going right now. So they are looking for people who are certified on AWS. They are looking for people who are certified on Azure. And at the same time, from a personal point of view, I would say that you can probably go ahead and demand the salary that you're thinking of, because you do have a certification that brings out an edge over another person, probably who's sitting for the same interview, right? So these are some of the benefits of doing certifications. But then what is the difference between a person who does one and a person who doesn't do a certification, right? So the difference is nothing but your marketing skills at the end of the day. So your interview duration is a little bit reduced, I would say, if you're doing a certification. But then if you're not doing one, if you still have the capability to market yourself, if you still have the comp skills, if you still have the confidence, it really doesn't matter whether you do a certification or not, right? So that's from my point of view. For people who keep asking me as to whether I need to do a certification, or do I really need to do one? Is it really that necessary, and so on? I would tell them gain the knowledge, because gaining knowledge any day isn't bad. So you can gain knowledge literally every day. So 1 hour a day, you can study for yourself, right? So it's very, very important that you do that. But then whether you end up writing the certification or not, that's totally up to you, because each and every certification has a cost associated with it. So for the associate level, it's around 10K, 10,000 Indian rupees. And then for the professional, it's around 22 to 23,000 Indian rupees. Similar for the specialty as that of the professional. For the foundational, it's around 7,000 to 8,000 Indian rupees. So when it comes to the dollars, I would say, foundational is $100, associate is around $150, and the professionals are all, including the specialty, is all $300, right? Yeah. So that's the cost when it comes to an AWS certification. So in contrast, Azure certifications are much less in cost, right? So that's the reason why I would say, if a person is asking me whether they actually need to do the certification, I would say it's totally up to you whether you want to do it. But then if you have the marketing skills, if you are able to market yourself with proper technical terms and then comp skills, I really don't think you would need to do a certification in the market. But if you want more challenges, if you want to always keep challenging yourself, probably go ahead and do one, right? So Gartner's Magic Quadrant in the year 2019, as of July, Amazon Web Services has been named for the 9th consecutive year as a cloud-based platform for infrastructure as a service. right? Every year they probably launch around 1,400 to 1,600 new services. It could be small configurations, but even those are called as services, right? And they are closely followed by Azure and Google Cloud Platform. And then under the niche players quadrant, you do have Alibaba Cloud, Oracle Cloud, and IBM Cloud, right? So there were a lot more different small niche players in the year 2017-18, I believe, but then they were, bought by other organizations who were in the leaders quadrant at that point of time, probably by Amazon Web Services or Microsoft and so on. So now comes the most important concept wherein we are going to study about AWS shared responsibility model. So this is very, very important in order to understand as to how AWS works, right? So in the shared responsibility model, you do have two people's responsibilities, as the name suggests. So the first person's of responsibility is AWS's own responsibility. So what are they responsible for? So they're responsible for security of the cloud. So security of the cloud in the sense, your underlying infrastructure, right? So their data centers that they take care of, having multiple backup lines, power lines into your data centers, having your cooling systems in place, having multiple internet lines to your data centers, ensuring that all of your racks are properly maintained, and having biometric scanners, iris scanners, different levels of access within the data center. So anything regarding the physical data center security is being taken care of by AWS. So you have three major components over there. One is called as regions. The second component is called as availability zones. And the third component is called as edge locations. So it's crucial to understand this. So there are regions are nothing but a geographical area where they have their data centers. So you have 23 regions, if I'm not mistaken, right? And an availability zone is nothing but a region can consist of one or more availability zones, wherein each and every availability zone is a collection of data centers, right? So if you consider the Northern Virginia region, you have 6 availability zones. You have US East 1A, 1B, 1C, 1D, 1E, and 1F. If you consider Mumbai as the region, you have AP South 1A and 1B as the 2 availability zones, right? So, and each and every one of these availability zones, the reason why it's called as an availability zone is because to isolate any kind of natural disaster that happens. So if suppose there is an earthquake in one availability zone, it would not, go ahead and, affect another availability zone. So it's always good to architect your application that utilizes multiple availability zone for highly available architectures and fault tolerant architectures, right? So one more benefit of using an availability zone is that you have low latency fiber optic cables that are connected through multiple availability zones, right? So in that way, you have very low latency when you're interacting within availability zones rather than from the availability zone outside to any one of the other regions, right? So, and each and every availability zone has at least 60 miles, I would say 100 kilometers, a distance between each, so that it isolates any kind of natural disaster that happens. So next, when we move on to edge locations, so edge locations it's like there are 216 edge locations right now, and these are all your caching servers is what I would call them as, and they enable you to provide low latency access to all of your data that you have residing within a region if you choose to use the edge locations, right? So probably if you want to go ahead and distribute your web applications content globally in the span of minutes, and you want to utilize all of these caching servers, you would probably go ahead and set up your edge locations through a service called Amazon CloudFront, right? So we will look at this on the map and then we will understand it much more in detail. So other than all of these three components, right, which are the regions, the availability zones, and the edge locations, you do have the four components over them, which is called as compute, storage, database, and networking. And literally most of AWS services, I would say most of all of AWS services come under either one of these four categories, right? So again, taking care of the security of all of these components are AWS's responsibility. But then when it comes to our responsibility, who is the customer who's using that AWS account, so we are responsible for security in the cloud, and our topmost priority is securing our customer data, and then securing our applications and the platforms that we are using, taking care of the identity and access management, which talks about authentication and authorization. And the next lecture is going to be regarding IAM, which is identity and access management. So how do we delegate access to a person to use our AWS account? What kind of access you're going to give that person, and so on. And then taking care of the operating system, patching and maintaining the operating system. Configuring your network and firewall configurations, whether it be network access control list on the subnet level,
or whether it be security groups at the firewall level, at the ENI level, right? So these are all things that we will have to configure because we are responsible for the inbound and outbound traffic to our application that resides within the AWS cloud, right? And then regarding encryption, I mean, going with server-side encryption or uploading your own encryption keys and going ahead and encrypting the data at rest using a key management service or using a hardware security module, which is FIPS 140 compliant, in order to store all of your secure keys and so on. It's totally your responsibility to do all that. And even going with the network traffic protection, having TLS certificate, SSL certificates created on AWS. So there is a particular service called Amazon Certificate Manager that provides you with free SSL certificates, which you can use within the AWS infrastructure, right? And you can get security in transit when you do, when you go ahead and use an SSL certificate, right? So all of these are your responsibilities, okay? So you have to remember this pretty clearly, because again, when we move on to some advanced concepts while we are going through this course, you will probably be, referring back to this particular lecture where you talked about the shared responsibility model and so on. Right? So let's look at what regions are. So this is a pretty outdated slide, I would say, because there are now 23 to 24 regions, and it spans across these multiple continents. So we have North America, South America, we have Europe, Asia, Pacific, and Middle East, these geographical locations, right? And one more thing to note over here is AWS has two regions that are in China, which can only be accessed by logging in through a separate portal, right? And then they also have two regions, I believe, for the government cloud agencies, which are called as AWS Gov Cloud or GOV Cloud. And you will not be able to list that on the console or be able to work with any of those regions because they are reserved for government agencies, right? So other than that, the other regions you can go ahead and use. So anyways, I'll be showing you all of this on the console when we log into the console, right? So regarding availability zones, I mentioned there are some key points over here. So they try to have minimal of typically 3 availability zones within a region. So they maintain up to more than 76, I believe, right now, availability zones across the entire world, right? And these are isolated portions of the global infrastructure. So they have their own power infrastructure. They are physically separated by a meaningful distance of at least 100 kilometers, which is 60 miles, right? So that even if there is a disaster in one, natural disaster in one availability zone, it doesn't affect the other availability zones, right? So therefore, you should go ahead and always architect your application to have high availability and fault tolerance, and even a scalable architecture. And through the, through the entire course, you'll be studying about how to do that, because this is Solutions Architect Associate, right? And all of the availability zones are interconnected with very high bandwidth, low latency networking with fully redundant, dedicated microfiber, providing high throughput and very low latency between availability zones. Network performance is sufficient enough to accomplish synchronous replication between AZ. And that's pretty cool, because we will be talking more about synchronous replication when we study about the database services. Okay. And again, if an application is partitioned to be deployed across multiple availability zones, are architected to use multiple availability zones, you are protecting yourself from any kind of lightning strikes or tornadoes or any earthquakes that might affect an availability zone. Right? So regarding the edge locations, we have now 216 points of presence. So this is again, it was taken a long back, this particular slide. So again, the security features that these edge locations provide you with are pretty cool, because it protects you from network and application layer attacks when you include a web application firewall in accordance with your, with your edge location, right? And then by default, you get SSL encryption or TLS encryption in transit by using HTTPS. You could go ahead and configure your own access control, wherein you can specify that this particular country should not access my application and so on. And the edge locations are all compliant with the underlying hardware with PCI DSS level 1, with Health Related Act for HIPAA, and with the ISO certifications, right? So when it comes to this map, again, this map is a pretty outdated, I would say, because we do have 216 right now. And the blue dots over here mention about edge locations. The purple ones mention multiple edge locations in that place. And this, the orangish circle mentions that there is a regional edge cache, which I would like to think of as a bigger cache in order to, save your data and so on for a longer period of time, right? So you do control over how long your object is stored within these caches, and that's called as time to live. So all of the networking people would be able to relate to that. So it's called as TTL. And when we work with the Amazon CloudFront service, you will be able to see that we will be able to configure our own TTL for as to how long our objects should be cached in all of these edge locations, right? So AWS does provide a free tier, so you can directly go to this particular link and you can go ahead and look at the free tier that they provide you with. It's for 12 months, and they will be deducting 2 rupees from your debit card, and then they will be crediting back to you that particular amount that they have deducted, and you pay for a monthly bill provided you go out of the free tier. So within the free tier, you have a lot of benefits that you get, and even some of the limitations that you see. So you will be able to go ahead and launch 750 hours of T2 micro capability for your virtual machine per month for 12 months. And then after 12 months, even that T2 micro is going to be charged, right? So for 12 months, you do get a lot of benefits. So you can go ahead and sign up for a free tier account. So all you have to do is go to this following link and create a free tier account, specify whether it's personal or for business. If it's business, you have to mention your organization's name. And then you have to sign up using a debit or a credit card. I would suggest going with Visa or MasterCard. Some people have, have had some problems when it came to my class. They were not able to create their own AWS accounts. And always validate your account using your mobile number, which will be in the next step. And then finally, once you get your account, wait for some time until AWS sends you a mail stating that your account is ready to use. Right? So now let's just log into the console and let's see how things look like. So you have the AWS management console. I have logged into this AWS account, right? And you can see on the top, we have the regions. We are right now in the Northern Virginia region, but then you can see over here, we do have other regions that we can work with. The reason, which region would be probably good for us to choose, right? So I would suggest choose a region based on a very low latency, which is closer to you. Choose a region where all of the services are available. Choose a region where the service cost is much lesser than the other region. And also choose a region based on where your customer is situated, right? So you can see that we have a lot of regions, 4 regions in the US, the US, area. And then you have Africa, Cape Town, which was recently launched. Then you have Asia Pacific, where you have 1, 2, 3, 4, 5, 6. And then you have Canada Central. And then you have 6 in Europe. And you have 1 in Middle East, which is Bahrain, and 1 in South America, which is Sao Paulo. So they have introduced a lot more regions recently, and they are striving to go ahead and release more. So other than regions, how do you see the availability zones, right? So you do choose a region, and then you go to the service called as VPC, which is called as Virtual Private Cloud. We'll be reading about this a little bit later when we go into the course in depth. So in this, you can see over here, when you go to subnets, you do see a lot of subnets. So let me switch to a region where I don't even have my infrastructure, right? So let me go to Seoul. Yeah. So whenever you purchase a new AWS account, every region comes with a virtual private network, right? It's a network where you do launch all of your resources, like your virtual machines or your database instances and so on. So each and every region comes with a default virtual private cloud. And you can see over here, your availability zones are mentioned over here. So for the Seoul region, you do have 3 availability zones: AP Northeast 2A, 2B, and 2C. And when you choose other regions, you'll be able to see the respective availability zones for that region. So you can use one of, you can go ahead and create a subnet for your virtual private cloud that is mapped to this particular availability zone. So one thing that I would like to mention over here is a subnet cannot span multiple availability zones. So you can't have a subnet that maps AP Northeast 2A, AP Northeast 2B. That's not possible. But then you can have multiple subnets in the same availability zone. That is possible. So you can have both of these subnets in the same availability zone. That is very much possible. But then you can't have a subnet that spans across multiple availability zones. So that is not supported by AWS right now. But I just wanted to mention that if you go to the VPC service, you will be able to see your availability zones over here, right? And then when we study about the Amazon CloudFront service, we'll be studying about edge locations and so on, right? So thanks a lot. I hope this introduction was enough for you to understand as to what AWS is. Don't worry about the VPC aspects. We are going to anyway study it in much more detail later. I just wanted to show you as to where you would find it on the console. Okay. So thanks a lot for attending this session. I hope you go forward with this course with me. So have a great day. Take care. Bye-bye.